Hey everyone, welcome back. In this lesson we're going to start a topic that's a little bit related to, well, it is definitely related to linear functions and the unit that we've been working on so far, but we're going to increase the level of complexity of the problem. So what we've been working on so far, you don't have to draw this in, what we've been working on so far, so when we started this unit we had our Cartesian plane looking something like this. We just had a positive x-axis, then a positive y-axis. Yeah, actually, definitely don't draw this in right now because I'm going to make this a lot messier in just a sec, and then we'll clean it up and move forward from there. So we started with this, and we got used to labeling the Cartesian plane. So we had our ways of labeling the x and y axes. Then we introduced the negative y-axis, so we allowed for negative values in the vertical direction, and then we expanded that out as well in the horizontal direction, so we had negative values out here as well. So we had our Cartesian plane looking something like this. We'd labeled our axes, we'd numbered our axes, and then we started drawing in some lines. So then we had some functions that, maybe we had a line like this, and we ended up exploring, different properties of different types of lines that, the different, for using the different slopes and y-intercepts that we examined so far in this unit. So we talked about what happens when you change the slope versus what happens when you change the y-intercept. But for a long time we were only working with lines that have a positive slope. Then towards the last couple of videos we talked a little bit about lines with zero slope. In the last video we talked about lines with an undefined slope, or basically what we were originally thinking of as perhaps an infinite slope. And then we also talked about lines that have a negative slope, so lines that look something like this, that go from the top left down to the bottom right of the diagram. So yeah, I hope you didn't try drawing this out because that's a lot of lines. So this is, not really a very good summary of what we've done so far, but we had some lines with positive slopes, some with zero slope, undefined slope, and negative slope. So these are, some rough sketches of some of the lines that we've worked with so far, but every single time we've only ever graphed one or maybe two lines on the same set of axes, but we've never really paid attention to where those lines cross. So if I give you a line, like this, and a line like this, if I give you these two lines, so that was our positive x, positive y, and we had these two lines, is there a way to figure out, well, I mean, sure, if we labeled our axes and everything properly, we could figure out the equation for each of these lines, we'd be able to figure out the slope and the y-intercept, and great, we'd be able to come up with an equation for this first line, so we'd have y equals something something for that one, and then for the other line we'd also have y equals something something as an equation for that line, which is great. But what about this point right here, where those two lines cross? Is there anything we can do with the equations that we have available to us to learn anything about this point? In particular, can we figure out what the coordinates, so what the x and y coordinates are of that point where two lines cross each other? So that's what we're going to examine in this video. And so you could say that that point is where these two lines intersect one another. So we call this right here, we call this the point of intersection. Now you don't have to write this down because we're going to do it again in a sec, because this was a really rough sketch. So don't worry about drawing that out. And basically what we're going to do, we're going to, in this video, we're just going to figure out how to find the point of intersection using an example, and then maybe we'll, in the next video, either we'll do another example, an example or two, or we will write out sort of a step-by-step process and then do one example. I haven't quite figured out exactly how I'm going to go about that in the next video, but we'll figure that out. So let's give this video a title, which is kind of jumping out at me that it should be points of intersection, so we will call it exactly that. So this is our 53rd lesson, I believe. Points of intersection. Squeezing that in over on that side. I started off way too big over here and then got way smaller over there. All right, sweet. Points of intersection. So that's what we're going to be working on today. So basically, so if you wanted to write down a definition, you can write it down. The point of intersection between two lines is, I don't want to say the point because we've got point in the definition here. You could say is the maybe the location, so like the location on your graph, the location where two or more lines, where the lines, I forgot we already wrote our two lines a bit over here. The point of intersection between two lines is the location where the lines cross each other. So you don't need to write down this definition. I mean, it's also hopefully fairly self-explanatory in the name, point of intersection. But so basically what we're going to be doing in this video and in the next video or two is we're going to work out how to find the point of intersection of two lines. And a lot of it is actually going to be quite familiar to you. So what we're going to do today is we will figure out the point of intersection between two lines, but we'll also see if it's maybe a little bit familiar to something that we've done before, namely in our algebra unit. So what we're going to do today is, maybe I'll give something away and mention exactly what we did before. That's very much like this, but I'm going to try not to. And what I'm going to do is I'm just going to work through one simple-ish example of how to calculate the point of intersection between two lines, and I'll see if you guys can figure out how similar the process is to something we did in our last unit. So even though this is a new concept, this is something that if you paid attention during the algebra unit and did well on the algebra test, this should actually kind of be a bit of a breeze for you. Now, of course, the added component is that on your linear functions test, there will be graphing questions. So some of the math will be really similar to what we've done before, but there will be a graphing component, which obviously we didn't really see very much of in our algebra unit because we hadn't done any graphing yet. So what I'm going to do is I'm going to get rid of this definition and actually also the title, just because it's kind of big. And what I'm going to do is we're going to draw our Cartesian plane, and we're going to plot some points so that we can build some lines. But what we're actually going to do, just because why not, is I will give you the equations of the two lines that we're going to be working with. So just so that we're not, plotting one point, a second point, then finding the equation of that line, finding the equation of the other line, and then finding the point of intersection. I'll just give you the equations, and then I just ask you for the point where they cross paths. So first thing we need to do is actually plot those points, so plot those lines on the graph. So we're going to have to draw this out, as we always do. Hopefully that's roughly horizontal. That's good enough. And we're not going to need a whole bunch of tick marks. 3 or 4 should do. X over there, Y up there. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, let's number those. 1, 2, 3, 4. -1, -2, -3, -4, -1, -2, -3, -4, and +1, 2, 3, and 4. Excellent. Okay, so hopefully you've got your Cartesian plane um, mostly set up. Just because we've got some time, I'll throw in some of these dotted lines. I say we've got some time. I mean, we've got some time in this video, although I should really be uh, trying to sleep at this kind of time. But why sleep when you can do math instead? Am I right? Okay, so those two look straight enough, at least, for the question that we're doing right now. Send this one right there. Hopefully that passes just about through the point that we need it to. Okay, that's close enough. It'll certainly serve its purpose. Whoops. It'll certainly serve its purpose as the placeholder that we kind of need, or as sort of like the landmark that we need while we're constructing our graph. Now in this lesson, I'm going to let you guys off if we happen to finish it a little bit early. Like if we happen to finish this example a little bit early, that'll be it for this video. Now I know I was actually meaning to put out a video last night, which at the time of recording today is Wednesday, so well actually that's technically Thursday morning. But I was planning on putting out a video Tuesday night, and I didn't, but I also didn't hear anything from you guys, so I think maybe with the long videos from last week, I got a little bit ahead of schedule. Maybe I should start from this side. Yeah, got a little bit ahead of schedule, so hopefully that's all worked out just fine. But yeah, so I was gonna put out a video then, and then let you off with this one, but if we happen to finish this one early, I'll just let you off anyway, because, you know, we're doing some complicated stuff. So, still gotta get this last dotted line roughly there. That should kind of do the trick. Something like that. Alright, and then one more down here. Let's get this one going across as well so that we can start plotting our equations. Alright, so there we go. We've got our Cartesian plane that looks something like this. And now I'm going to give you two equations. So your first equation that we're going to graph is, let's see, I worked this out earlier to make sure I didn't make any mistakes. This is going to be y equals 2x minus 2, which I believe is actually one of the first ones that we graphed in the first or second lecture, and I say lecture, the first or second lesson, since we started this unit. I think we graphed this particular function, or one very much like it, very early on. But anyway, so we're going to graph it one more time, and then we're also going to graph y equals negative 1/2 x plus 3. So a little bit more to unpack there. We've got a slope that's not only fractional, but it's also negative. So we've got a little bit of work to do there. But we'll start as we always do. Let's start by plotting this first function. So what we're going to do is we're going to start by identifying. So if we're talking about line number 1, then we just need to identify the slope and the y-intercept, and then we can get going. Slope and y-intercept. Now if we look at the equation of the line here, we can see that the slope is going to be this thing that's sticking out in front of the x, so we got a positive 2 for our slope, and then for our y-intercept it's going to be the thing sticking out the back, but we have to carry the minus sign, so our y-intercept is negative 2. Now remember, our y-intercept tells us where we plot our first point on the y-axis. So we'll start off by plotting a point at negative 2. So that's our y-axis, that's our y-intercept, our point on the y-axis for the first line. Now, if we have a slope of 2, that's the same thing as having a slope of 2 over 1, right? And if we write our slope as a fraction, then it's very easy to see using the rise over run format. Right, we got rise over run is equal to 2 over 1. That's telling us that the rise must be 2 and the run must be 1. So if we go from our starting point and we follow a rise of 2 and a run of 1, we start from here, we go up 1, 2, that's our rise, and then we go over 1, and that'll put us right there. And that's our first point. Now, again, once you've got 2 points on the line, you could just take some sort of straight edge, so like a meter stick, or, you know, for you guys, just a regular ruler or the side of a notebook or the edge of a calculator or something would even do the trick. Maybe the side of an iPhone would do the trick for you as well. Once you've got the first couple of points down, you can just draw the line straight through there, but for the sake of working with the board, I'm going to draw in at least one more, possibly 2 more. So from here, if we repeat the process with the slope, we have a rise of 2 and a run of 1. So from here, we'll go up 2, so 1, 2, and then we'll go over 1 to right there, and plot our point right there. So hopefully you can see how I got there. From here we went up once, up a second time, and over. So that gave us our rise of 2 and our run of 1. And so that's exactly what we needed to get that second point in there, or I guess I should say third point. And let's go ahead and connect these now. I'm going to start from up here. Something like that is our first line. And so it's good practice when you finish drawing your linear function that you write the equation of the line that gave you that graph. And it's especially important now because we're going to be plotting 2 functions on the same Cartesian plane. So we're going to be plotting a second line on top of this graph. So now it's important to label which line we're talking about. If you don't feel like doing the equation or you're running out of space, then you can just put 1 in a bubble like the 1 and 2 that we've got over here. So whatever labeling system you use for your equations, if you can at least put that over there so that we can tell what line we're looking at, then that's great. But it's even better if you can write in the actual equation. All right, for line number 2, let's get rid of this stuff from over here. Let's get rid of this. We'll get rid of that. And I'll change the 1 to a 2. So you guys are going to need a second to sort of recopy that out into your notes. Because, of course, I don't have to rewrite slope and y-intercept. But what do we have here? So I've got this rise over run fraction just kind of sitting in the middle of nowhere. Now it's, but we'll fill that in a second. So if we look at our slope for equation 2, that's going to be the bit that's sticking out in front of the x, which in this case is quite a lot. We've got a negative sign and we've got a fraction, so lots to unpack there. But for now, we don't have to unpack anything. We're just going to carry the whole thing over right to there. But I'm actually going to rewrite this ever so slightly because right now we have negative 1/2. But just to remind myself when I'm graphing, I'm going to stick the negative up there in that numerator. It's mathematically, it's the same thing. I haven't changed anything. But I'm going to throw it up there for when we're actually graphing it. It's easier to have the negative either stuck to the numerator or stuck to the denominator. And as I mentioned a couple of videos ago, I personally prefer to keep that negative sign stuck to the numerator. So that's what we're doing. And then our y-intercept is the thing that's sticking out at the end. And because we've got a plus sign, we don't really need to write in the plus, but we don't have to carry a negative with us. So that's kind of nice. So then we get that our slope is negative 1/2, and our y-intercept is 3. And I went right through the 3 with my circle there, but you get the idea. Great, so we figured out our slope, we figured out our y-intercept for this line. Let's get to graphing. So we start with plotting a point at the y-intercept. So in this case, we've got a y-intercept of positive 3, so we start at the origin, we go up 3 units to here, we plot a point right there. And that gives us our first value. Now from here, we got to make use of our slope. So what the equation is telling us is that our slope is negative 1/2, that's great. And so what we get is that the rise is negative 1, and the run is positive 2. So what we're getting from this equation. So, if the rise is -1, that means we're falling one step. We're going down for our rise instead of up. And then for our run, if the run is positive, we're still moving to the right. So if we start with a rise of -1, that means we go down one spot. So we go down one spot to here. And then we have to go over 2 spots because our run is 2. So we go over 1, over 2, and we get a dot right there, which is right over top of one of the dots from before. Hint, hint. But let's go through that process one more time just so we have another dot to plot. So if we plug in one more, or we do that process one more time, we go down to here, and we go across 2 spots to about there. And so then you can fill in, you can sort of connect the dots there with those 3, and you should get something that looks something like that. It's a little bit wonky, mine. I've got a little bit of a curve up here that there shouldn't be, but there's a rough idea, and we'll just squeeze in the equation over here. Y equals -1/2 x plus 3. Just sneak in that equation there so that we have both lines labeled. Now what we need to do is we need to figure out the main idea of this video, which is the point of intersection. So to do that, I'm going to get rid of the equations from here since we've written them over there already, but I'll also actually throw in that label of 2 with a bubble. So we got 2 with a bubble. Great. So we got line 1 and line 2, much like thing 1 and thing 2. All right, great. So if you're graphing the lines, it's not that hard to figure out the point of intersection every time. Now, if you're just eyeballing the graph, for a more complicated function, you might think something is the point of intersection when it's not actually. So like you might think, like if you've got your grid lines going like this, right, and you've got your grid lines going like that, you might think that you've got a point right here in the corner, but the point is actually a little bit over this way. And so your line doesn't actually run right through that corner point, but you'll be like, it's close enough. If I don't have a dot there, it looks really close to that corner, so I'm just going to pretend it's that corner. We'll make a huge dot so that it looks like it fits there. Yeah, no, that doesn't work. So when we're actually drawing out these linear functions, it'll be fairly clear if your line intersects a point exactly, but that's also depending on how carefully you're able to draw it out. Because sometimes you'll have those close calls where you've got a grid square that looks like this. I mean, I should have maybe done that with dotted lines again, but you've got your grid squares that look like this, but then your line passes really close to the corner, but not actually through the corner. So you can't say that if you've got a second line that's passing like this, if you've got your 2 lines look like that, you can't say that your point of intersection is right at the corner here. It's some distance away, and we need to figure out exactly what the value is at that point. So when it comes to your test, it'll be fairly evident if it goes directly through the corner. Otherwise, I will tell you, this is the value you should expect, but graph it for me. Graph the 2 functions and show me the point of intersection. Now we can see that the point of intersection is just where the 2 lines cross. So I'm going to put a little circle around that so that we can see that that's the point that we're interested in. Now if we confirm from the graph, we know that we plotted that exact point in both functions. So we know that it's exactly where we think it is. And so we could just read it off the graph and get that our point of intersection, or POI, point of intersection, is equal to, and then just whatever our x and y coordinates are. So let's eyeball it from the graph, and then we'll work it out with some math. So if we're using the graph for this, we get that it's got an x value of 2, but also a y value of 2. So the coordinates of this point in here must be 2, 2. So we get point of intersection 2, 2. Perfect. So that tells us what our point of intersection between these 2 lines is. Now we're going to approach the same idea mathematically, and you might recognize some similar math. Depends on how much attention you've been paying in your classes. All right, so now what we're going to do is we're going to use a mathematical approach to figure out these two, the point of intersection of these two lines. Now let's remind ourselves of the equations. If I rewrite the first one, we got y equals 2x minus 2. And if we rewrite the second one, we got y equals negative 1/2 x plus 3. Don't write those down. If you already have, then don't worry about it. But if you haven't written them down, don't start writing them down right now. I don't know why I'm yawning so much in this video. All right, points of intersection are definitely more interesting than the yawns might indicate. But anyway, at the point of intersection, you might notice that the y value has to be the same. I mean, actually also the x value needs to be the same, but in particular, the y value needs to be the same for that point in both lines, which means that this